Solving linear inequalities by Bethany. A linear inequality is in one variable can be written in one of the following forms where a and b are real numbers and a does not equal 0. Ax plus b is less than 0. Ax plus b is greater than 0. Ax plus b is less than or equal to 0. Ax plus b is greater than or equal to 0. Graphing simple inequalities. X is less than 2. The solutions are all real numbers less than 2. An open dot is used to indicate 2 is not a solution. Then you write it on the number line. X is greater than or equal to -1. The solutions are all real numbers greater than or equal to -1. A solid dot is used in the graph to indicate -1 is a solution. And then you put it on the number line. Graphing compound inequalities. -1. Well, first, instead of -1, reading it like that, you got to go from the middle and read it. X is greater than or equal to -1, or x is less than 2. The solutions are all real numbers that are greater than or equal to -1 and less than 2. But it can also be written as x is greater than or equal to -1 and x is less than 2. And there's a line and it connects because it's in between those two numbers. X is less than or equal to -2 or x is greater than 1. The solutions are all real numbers that are less than or equal to -2 or greater than 1. They point in opposite directions on the number line because they are not compound. They are compound, but they do not connect. They go in their opposite directions. An inequality, solve an inequality with a variable on one side. So 20 plus 1.5g is less than or greater to 50. You minus the 20 on both sides. And then it turns to 1.5g is less than or greater than 30. And you divide it by 1.5 and you get g equals 28. And there's the number line. 25 minus 5p is greater than 15. You add 25 to both sides. You get -5p greater than 40. You divide it by -5. P is greater than -8. There you go. Solve an inequality with a variable on both sides. So 5x plus 2 is greater than 7x minus 4. You minus 7x on both sides. -2 plus 2 is greater than -4. You minus 2 to both sides. -2x is greater than -6. You divide it by -2. X is less than 3. You have to reverse it inequality whenever you divide by a negative. And there's the number line. So 2x minus 3 is less than or equal to 5x plus 12. You minus 5x from both sides. You get -3 minus 3 is less than 12. You add 3 to both sides. -3x is less than 15. You divide it by -3. X is greater than or equal to -5. Solve an and compound inequality. -4 is less than 6x minus 10, which is less than or equal to 14. 6, you plus 10 from both sides, and then 6 is less than 6x less than or equal to 24. You divide by 6 on all sides. Now, x is greater than 1 or less than or equal to 4. And there's an and inequality. It connects, like before, it connects because it's in between. Solve an or compound inequality. 3x plus 5 is less than or equal to 11, or 5x minus 7 is greater than or equal to 23. We'll do this one first. You minus 5 from both sides. It comes to 3x, which is 3x less than or equal to 6. You divide by 3, you get x is less than 2. You plus 7 from this side, from at both sides, you get 5x is greater than 30. You divide by 5, x is greater than 6. A solution of this compound inequality is a solution of either of its parts, meaning it could be either a solution on one side or the other, or even both. Thanks for watching.